In this video, I'm going to be talking to you about operations with radical expressions. When adding or subtracting, expressions with radicals uses the process of combining like terms. For terms to be combined, their radicands must be the same. It's a lot like adding and subtracting with variables. To add and subtract, you can only combine like terms, which means that you would use the same variable. When you're doing it with radical expressions, you have to have the same radicand, okay? Multiplying two radical expressions with two terms is similar to multiplying binomials. The radicands don't have to be like radicands with multiplying, also like when you're multiplying with variables. So the same rules pretty much apply to radicands as do variables with adding and subtracting and multiplying and dividing. All right, so in number one, I'm going to show you how to simplify this. So just like if you were to have 6x plus 2x minus 5x, you get 6 plus 2 is 8 minus 5, and you get 3x. The same is true for this. So 6 plus 2 is 8, minus 5 is 3, but you have the square root of 5, and that's your answer. So number 2, when I'm combining like terms, I have 7 square root of 2 minus 6 square root of 2. That would be 1 square root of 2, or just the square root of 2 because the 1 is assumed. And then 8 square root of 11 minus 4 square root of 11. So 8 minus 4 would be positive 4 square root of 11. And that is your answer. You can see in number 3 that none of the radicands are alike, but they need to be simplified. So the square root of 27 is not a perfect square, but 9 is. And 9 times 3 is 27. 8 square root of 12. 12 is not a perfect square, but 4 is. And 4 times 3 is 12. 75 is not a perfect square, but 25 is, and 25 times 3 is 75. So now let's break this down. So we have 6. I'm just going to drop that down. Okay. The square root of 9 is 3, and this 3 stays inside. The square root of 4 is 2, and the 3 stays inside because you can't do anything with it. The square root of 25 is 5, and the 3 stays inside. So let's simplify this. So 6 times 3 is 18. 8 times 2 is 16. 2 times 5 is 10. So 18 plus 16 is 34. Square root of 3, and then plus 10 square root of 3. So 34 plus 10 is 44 square root of 3, and that is your answer. Okay, number 4. Notice the radicands are different. You've got 3 and 6, and that cannot be, neither one of those can be simplified. So you would just write in that case already simplified. There's nothing else that you can do. Be careful when you're answering already simplified because not many of them will be. Okay, when you're multiplying, it's very similar to multiplying binomials. So this would be like multiplying a monomial and a binomial, which actually is exactly what it is. So we're going to multiply the outside numbers together and multiply the inside numbers together. So 4 times 3, and you're going to distribute too, I'm sorry. So 4 times 3 is 12, and the square root of 2 times the square root of 2 is the square root of 4. Then plus 4 times 2 is 8, and the square root of 2 times the square root of 6 is 12. So notice that I multiplied the outside numbers and my radicands together. Outside with outside, inside with inside. Okay, now let's simplify this if we can. So the square root of 4 is 2, so I can do that, which we know is going to be 24. And then over here, 12 can be broken into 4 and 3. The square root of 4 is 2. We leave the 3 inside. So I get 24 plus 16 square root of 3, and those are not like terms, so that's as far as I can go. This is another problem just like the one that we already did. None of the radicans are the same, but I have to simplify them. Okay, so 8 would be 4 times 2. 125 would be 25 times 5. 32 is 16 times 2. And 45 would be 9 times 5. Okay, let's see what we can do with this now. The square root of 4 is 2, so I'm going to leave that for now. The square root of 25 is 5. The square root of 16 is 4. The square root of 9 is 3. Now let's combine the 3 times 2 and get 6, square root of 2. And then I'm just rewriting the rest because it's already simplified. Now I'm going to combine like terms. So I have 6 square root of 2 plus 4 square root of 2. So that would give me 10 square root of 2. Then I have negative 5 square root of 5 plus 3 square root of 5. So negative 5 plus 3 is negative 2 square root of 5. And that is my final answer. All right, now we're going to multiply a binomial times a binomial with distribution. So we're just going to distribute the distributive property. Okay, so first I'm going to multiply 3 square root of 2 to 4 square root of 6 plus 1. So 3 times 4 is 12. And then the square root of 2 times the square root of 6 is also 12. And then 3 square root of 2 times 1 would just be 3 square root of 2. Now I'm going to multiply the 4 times everything in the second binomial. Okay, so I've got negative 4 times 4 square root of 6 would be negative 16 square root of 6. And then negative 4 times 1 would be negative 4. Now, the only thing that I can break down here is the square root of 12. So I'm going to say the square root of 12 is 4 times 3. And then I can't simplify any of these, so I'm just going to leave them as they are. Okay, so I'm going to get 12 times the square root of 4 is 2 square root of 3 plus 3 square root of 2 minus 16 square root of 6 minus 4. When I do that, 12 times 2 is 24. And then I'm just going to leave all of this as it is because I can't combine any like terms because all the radicans are different. Number 8, what we have is a sum of a square. So from previous lessons, you know that you can split it up and write it twice like this and just distribute. So we can do that if you want to. Or we can also square it, multiply, and double, which is what I'm going to do. Okay, so if I square the 5, that's 25. If I square this, 3 squared is 9. And then the square root of 2 squared would be the square root of 4. Then I'm going to multiply these together, and I would get 15 square root of 2. And then double, and we get 30 square root of 2. Now, I can also simplify that last term. So 25 plus 30 square root of 2 plus 9 times the square root of 4 is 2. So you get 25 plus 30 square root of 2 plus 18. And when I add those together, I get 43 plus 30 square root of 2. And that's my answer. Now, if you feel more comfortable with the distributive property, I can show you that on this side. I get 25 plus 15 square root of 2 plus 15 square root of 2 plus 9 square root of 4. I can combine these two in the middle to get 30 square root of 2. And then the rest of the problem is the same as what we already had. So whichever way you want to do it, I'm fine with, as long as you show your work no matter which way you choose to work it out. Okay, this is the hardest problem on here, and I'm sure you can already see why. It's because there's a fraction. And we know that we can't leave any radicals in the denominator. We also know that we have to combine all like terms. So let's just kind of go through this, starting out by simplifying. So in the first term, you can't really do anything. So 2 square root of 3. In the second term, 45 is 9 times 5. And this third term, I can change this. Watch, the square root of 1 is just 1. And I can leave it like that, the square root of 3. Now, that's kind of messy, so I'm going to clean it up in this next step. So I've got 4 times the square root of 9 is 3. Watch what I'm going to do here. I'm just going to take this and go 2 over the square root of 3, because 2 times 1 is 2. So I can write it like that. So my next step, again, to simplify things a little bit, negative 4 times 3 would be negative 12, square root of 5, plus 2 over the square root of 3, which would be great, except there's a radical in the denominator. So I have to rationalize that by multiplying top and bottom by the square root of 3. When I do that, let's see, I would get 2 square root of 3 over 3. Well, what you can see here is that this last term and this first term both have the square root of 3. Those are like terms. So even though one's a fraction and one's not, it's still like terms because it's the square root of 3. So this is where people kind of go wrong because they don't finish the problem and they think they're done, but they're not. So I have to get a like denominator. So since this third term is over 3, this is going to have to be over 3, and I can do that. Okay? So I'm going to finish over here on the right. So 3 times 2 would be 6, square root of 3 over 3, minus 12 square root of 5, and then plus 2 square root of 3 over 3. Okay, so I have 6 plus 2 square root of 3. So that would be 8. Here we go. 8 square root of 3 over 3 minus 12 square root of 5. And that would be my final answer.